Practice test 4, problem 6. We're supposed to graph the solution to the system of inequalities below. When we're graphing solutions to systems of inequalities, first thing we need to do is sketch the line that's created by the equation that goes with the inequality. We need to make sure that we pay attention to whether it should be solid or dotted. And then we determine which side to shade, usually by using a test point. So I'll go ahead and graph the first one. The x and y intercepts of our first inequality would be 12 and 12. You can figure that out quickly using a small table. If we had x being 0, then that would just read y is equal to 12 if we were treating this as an equation and not an inequality. So we would have 12 there. And then if we switch that around and put in 0 for y, then x would be 12. So I'll go ahead and graph those intercepts. Positive 12, positive 12. And this inequality symbol does not have a line underneath it, so I need to connect these 2 points with a dotted line. And I'll go ahead and figure out what side to shade right now. So I'm going to use 0, 0 as my test point. And if I plug in 0, 0 to this inequality, then that would read 0 plus 0 is greater than 12. And that, of course, is not a true statement. So I would shade the other side of this line. Now I'll switch colors for the next one. This equation is written in slope-intercept form, so it's going to have a y-intercept of -6, and then a slope of 1/2, meaning every time I move up 1 unit, I'm going to move forward 2 units. So I can use that to graph a couple points. And this inequality symbol does have a line underneath it, so I'll go ahead and graph it using a solid line. And then it looks like it's okay to use the same test point. The only time you can't use 0, 0 is if the line goes through it. If I plug 0, 0 into that inequality, it would read 0 is less than or equal to 0 minus 6. 0 less than or equal to -6. And that's not true. 0 is not less than -6. So we would not shade that side. We would shade the other side of that line. Finally, for our last inequality, I'm going to go ahead and use a little table again and identify the x and y intercept since it's written in standard form. So if I plug in 0 for x, y would be 6. If I plug in 0 for y, x would be 2. So we've got positive 2 on the x-axis, positive 6 on the y-axis, and this would be graphed with a dotted line because there's no line under this inequality symbol. I'll use a dotted line here. And again, I can use 0, 0 for my test point. So if I plug that in, this would read 0 is less than 6, and that is true. So this time I will shade the side with the test point. And for this system, now that I've got all my shading done, I don't see any regions where all 3 inequalities overlap with each other. So maybe 2 of the inequalities overlap with each other, but in order for this to be a solution to the entire system, there has to be a place where all 3 regions overlap. And so together as a system, this has no solution. Okay, now let's take a look at part B. This time we only have 2 inequalities to graph. For the first one, x minus y greater than 0, finding the intercepts in this case doesn't really help because the intercept is going to be at the origin at 0, 0. and so we need to figure out another point that we could use. I'll just plug in a random value for x to find another value that I can graph. So let's say that I make x equal to 5. Then this would read 5 minus something greater than 0. To graph the line, I need to know what to put in there so that it would be equal to 0, and so that value would have to be 5. So another point that I could graph would be 5, 5. And that's always a strategy that you can use. Just plug in some value for x and figure out what the corresponding y value should be to figure out a point on the graph. Both of these do not have lines underneath the inequality symbol, so they're both going to be graphed with dotted lines. And this time, since the line goes through 0, 0, I can't use that as my test point, so I need to pick something different. I think I'll choose 0, 5. I'll choose this point right here. So test point of 0, 5. I'll plug that into this inequality here, so that would read 0 minus 5 greater than 0, negative 5 greater than 0. That is not true, so I'll shade the other side of this line. And now let's repeat the process for the other equation. This time I can go ahead and use the intercept method since I've got a number over here that's not 0. I'll set up a small table. If x is 0, y would have to be 8. If y was 0, x would have to be 8. So I'll find 8 on the x-axis, 8 on the y-axis, and connect those 2 points using a dotted line. And this line does not go through 0, 0, so I can use that as my test point. And that would read 0 plus 0 is less than 8, which is true. So I will shade the side of that line that contains my test point. And now we can see where our two shaded regions overlap. So the final solution to this entire system, the regions that are true for both inequalities, is this region down here. And this is how we show our solution, just using a graph and making sure to indicate which of the shaded regions is our final answer. So this here is our feasible region.